again a block is placed, no? So if you place a block, okay, no, we'll write equations. So what all things? So let's assume some. All of you read question. I'll proceed with this. So let what all we do assumptions. I think I can construct another diagram in it. We'll see later on. Let me proceed here. So this will be H. Initial some assumptions I'll make it because I had to write manometric equations. What is the state of spring? So let me take this is say some H2. Now spring it will be compressed or elongated as not given anything. Spring is compressed or elongated, not given. I think the liquid is there. So definitely it must be compressed, no? The spring is compressed. So how the spring force will act like this, Kx naught. Okay, let's write the manometric equation. I will start from B, from the piston. Pistons are massless. Are you able to notice that? Without friction in vertical arms, the piston, the arm is supported on an equidistant length of the tube. What maximum additional mass can be gently placed on piston? This one. So that in arm will be remain inside the tube. So shall I proceed here? It will be, so we'll neglect atmosphere, neglect atmosphere. P naught I'll write here. To minimize calculations, or better say P naught. Okay, let's write the equation. So I'll write, so how to write manometric equation? Say I'm writing manometric. What is the pressure at B? Kx naught by SB minus, if I move inside the liquid vertically up, gauge pressure should be negative, plus rho GH minus rho GH1 equal to 0. Once again. But sir, here, how come spring force will set up a pressure here? Not, it need not be always from liquid, no? Here you can see that. Now you have to ask one beautiful question here, like, sir, liquid will exert force at all points, but spring force is acting only at one point. How can you write pressure? Say like the spring force, what is acting is on the piston, no? And the piston will exert force on the liquid. So Kx naught by area of cross-section of piston will be the gauge pressure by the spring force. If I move inside the liquid, minus rho GH by 2 plus rho GH minus rho GH1. I neglected P naught. If you want to take P naught will get eliminated. Again, lot of confusion. So that's why I just neglected this one. So here, so what happened? The pistons are massless. If the piston were having a mass here, then MAG by SA, area of cross section of that. So there's the one equation, you keep it here. Okay, after placing the load, I think it's all about the diagram. Huh? Let me take it. After placing the load, okay, I think I can't draw. Let me draw it to the same level. Okay, I tried my level best to get a better diagram. So after placing the load, so let it come down. And this piston will be in this position. Okay, let this be H. Okay, this will be H2 plus L. And spring how much it will be compressed? K X naught plus L. Okay, fine. So this is the thing, no? So what happened? The amount of liquid which is present here, the amount of liquid present in this region where it has gone, it has increased here, no? This much of the liquid has come here. So shall we go for like a mass of the liquid should be conserved. So therefore, the liquid that got displaced in the column A, the amount of liquid that got displaced from column A should appear in the column B. So therefore, as the density, so mass should be conserved. So rho SA H1 minus H should be equal to rho SB into L, or SA H1 minus H. Keep it one. Volume of liquid, or decrease in volume of liquid in column A should be equal to increase in volume of liquid in column B. I don't have everything, so I'm just explaining it. I can't write so much of things. So from this is what? Comparing the volume of liquid should be conserved here. Okay, fine. Next again, come for this diagram. So can you write any manometric equation here? So there's a spring constant K. So let's go for again writing manometric equation. K minus rho G H2 plus L plus rho GH minus rho GH minus mg by SA equal to 0. Why mg by SA? So look at the manometric equation K x naught plus L SB, area of cross section SB, here SA, no? Manometric equation. Spring force by area of cross section of piston minus rho G H2 plus L plus rho G H capital H minus rho G H mg by SA, where I end up negative, all set equal to 0. So on, okay, let's do one thing. Kx naught by SB minus rho GH2, and okay, this particular quantity will become everything equal to rho GH1. So can we substituting? So put 1 in 3. Kx naught SB minus rho GH2 plus rho GH can be replaced as rho GH1. So rho GH1 plus KL SB minus rho GL minus rho GH minus mg by SA equal to 0. This is called equation 4. Or if you will simplify one more step. I think I'll keep it this much. Writing equations will be easier. Okay, shall I take out this much? We'll have enough space to write all the things. Now come for this one. So this will become rho G H1 minus H minus rho GL KL SB minus mg SA equal to 0. Rho G H1 minus H. You can write it as SB into L. So substituting this, you call equation 4. 3 in 4. So there should be rho SBL rho GL plus KL SB. I think almost it's all, no? We are very near to the answer. So what is the question? So SBSA. So what is our question? What we are supposed to find out? What additional mass expression for M? So can you simplify for M? All the things are known. L is given, K is given. So we have to solve for M. It's all about manometric equation. Huh? SB in terms of SA, you can write it and solve for M. Anybody simplify? What is L? L is also known thing. Anybody value? Or shall I write directly answer? Will you verify? I'll go for next question. So all things are known. So SB equal to eta SA, something is telling. So from that the SA will get eliminated, SB will get eliminated. So the final answer, I'll write it. KL eta G. What is, I think, some data. SB equal to eta times of SA. From there that eta will come. This is given. And this will be our answer. Manometric equation. I don't think so anything very big with this problem. It's all about writing manometric equation. I'll show the total problem. Okay, wait.